Hello everyone, my name is Minh Duc Pham and this is my BUSA2020 project, analyzing the Sydney housing market and the impact of distance and property size. This project is real data to explore how distance and land size influence property prices and rent. Here's the roadmap of my project. We'll start with the introduction, then apply our business questions using data and visualization and Excel regression. Each part includes a hypothesis test and decision. We'll finish with a discussion and conclusion. We all know that Sydney's housing market is one of the most expensive in the world. It's commonly believed that location and size strongly affect price and rent. This project tests those assumptions using real data and regression analysis. In this project, I apply key BUSA 2020 topics, which includes descriptive statistics, hypothesis testing, simple linear regression, data visualization, and business interpretation. This project has two parts. Part 1 tests the effect of distance to CBD on house prices. Part 2 tests whether property size affects weekly rent. The data comes from domain and real estate for 2024 listings. I collected values for 10 suburbs, including distance to a CBD, median house price, and weekly rent. Coming to part 1, we analyze the impact of distance on house prices. The method includes hypothesis testing and regression using Excel. So the question is, does distance affect house price? We have the null hypothesis is distance has no effect, and the alternative hypothesis is distance affects house price. So right now I will perform the test on Excel. So here I have the data here. So first we need to have a scatter plot to have an overview about the data. So we choose that, come to insert, click recommend chart, whole chart, X and Y scatter, put it here. So right now we have an overview about the data. So I have decorated it. So right now we have to see that we can see that a trend that as the distance to the CBD increase, the median house price decrease. So now we will perform the regression to see if my prediction is true. Come back to regression. Now choose the data, go to data, click data analysis, find the regression, click OK. In the input Y range, I choose median house price because it is a dependent variable. In the X range is distance to CBD, which is an independent variable. Make sure to click labels. Output range, we can choose this one, the residuals and residuals plots, and click OK. Now we have a summary output here. We just need to pay attention to these values. The p-value, the r-square, and the intercept and coefficient. So coming back to the slide, I have this regression summary here. So the p-value is well below 0.05, so the result is statistically significant. The r-square shows that about 80% of the variation in house prices is explained by distance. This means the model fits the data well. The slope means that for every extra kilometer from the CBD, the house price decreased by around $34,700. The intercept show that This is the estimated price of the house located at 0 kilometers from the CBD. Let's take an example right in the city center. So these results clearly show a strong negative relationship. By that mean, we know that the p-value is less than 0.05, so we reject the null hypothesis. Then we can conclude that distance to CBD significantly affects house price in Sydney. So right now we are coming to the second part. It's just another example. So part 2, which looks at whether land size affects weekly rent. Again, we'll use regression and hypothesis testing. So the question is, does property size affect rent? The null hypothesis is property size has no effect, and the alternative hypothesis is property size affects rent. Right now we're coming to the second data. Here I have the data again. We need to create a scatter plot, recommend charge, x and y scatter. Here you can have a look at it. It's quite random. So we're moving back to here. I have to decorate it again. Here we can see a trend here. This scatter plot show a mild upward trend. Larger properties might rent for more. Let's test that statically. So coming back to Excel, I choose the data, go to data, choose analysis, regression. Here we have the same. And click OK. Here, mine the R square again, the p-value, the intercept coefficient. Coming back to the slide, I have made a regression summary for you. So now I will explain each metric again. So the p-value is 0.0575. This is slightly above 0.05. So the relationship is not statistically significant. The R square is about 38% of the variation in rent is explained by land size. This is a moderate fit. About the slope, surprisingly, the slope is slightly negative, meaning the model suggests rent decrease with land size. But again, this is not statistically significant. The intercept, this is the model prediction for rent when land size is 0, which isn't realistic, but it helps define the regression line. Overall, this model suggests a weak and non-significant relationship. So, because the p-value is greater than 0.05, we fail to reject the null hypothesis. This means land size does not significantly affect weekly rent in this dataset. So after 2 examples, of course there are different results, but this project shows the power of using data to test assumptions. While distance clearly affects house price, property size did not show a strong link to rent. Future work could include more variables like property condition, location, and nearby services, such as amenities, transport, schools, and etc. So coming to the conclusion, to summarize, distance from the CBD has a significant effect on house prices. Land size does not significantly influence rent. These insights show how data and regression help make informed business decisions. Coming to the references, I collected data from domain, real estate, and distance measurements were taken from Google Maps. Thank you for listening. I hope this presentation has given you useful insight into Sydney's real estate market.